Question 12. Jason and Mark shared some sweets in the ratio of 2 to 3. Jason, who received the larger share, received 12 sweets. You have to be careful here. In the exam, you have to be careful with each question. Don't rush it. The technicality in this question lies in this second line. It said Jason and Mark shared some sweets in the ratio of 2 to 3. That means you'd have thought that Jason's ratio was 2, Mark's ratio was 3. But it doesn't work that way. The second line of sentence is pointing to you not just the amount of sweets Jason received, but also Jason's ratio. It says here, Jason, who received the larger share, received 12 sweets. That means Jason takes the larger ratio, because you have it as 2:3. The larger ratio shows who receives the larger share. So if Jason receives the larger share with 12 sweets, that means it takes ratio 3. And to solve this question, we can use what is called the equivalent method, where we have to equate the ratio of a person to the number of sweets he got, and with that, taking into consideration the relationship between the ratio and the actual amount the first person received, we can use that with the second person's ratio to get the amount of sweets the second person received. Let's just solve so you can better understand. If Jason's ratio is 3, the larger ratio, and he received 12 sweets, that's 3 is equivalent to 12. Mark has the smaller ratio, which is 2, is equivalent to the amount of sweets he would receive. You can see the ratios align, the number of sweets should also align. We can say Mark's share of the sweets is X. So 3 is less than 12. And in this case, when we're working with ratio, we take into consideration what we can multiply this 3 by to give you 12. Or you can say 12 divided by 3, that's 4. That means you multiply 4 by 3 to give you 12. That's the relationship between Jason's ratio and the number of sweets he received. That's times 4 will give you 12. That's like the constant. So for Mark too, the constant applies. So we'll take Mark's ratio, which is 2, and multiply it by 4 to get the amount of sweets Mark will get. 2 times 4 will give you 8. That means Mark received 8 sweets. So you can have this as 8 sweets. We can also solve with a method similar to this but quite different. That is, you cross multiply to get the number of sweets Mark will get. We have Jason's ratio as 3. The number of sweets he received is 12. You can say this is equal to or equivalent to 12. For Mark, his ratio is 2. That's equivalent to taking the number of sweets he received as X. We cross multiply. We say X times 3, that's cross and multiply. X times 3 equals, on the other side of equals sign, you have 2 times 12. 2 times 12. We have X times 3. You don't need to multiply X times 3. If you multiply it, still the same thing. You have 3X, or you can leave it like this, equals 2 times 12, that's 24. Since we're looking for X, and X is linked to 3 by times, the inverse is dividing by 3. Divide both sides by 3 to get the 3 of the X, so the X can stand alone. We have 3 cancels 3. X equals 24 divided by 3 would give you 8. So we get the same answer using methods that are quite different. But this second method is best in case you are having a situation here where you don't have a whole number as your constant. It might be a fraction. So when you are getting that complication, you can just cross multiply to get your results. Question B says, how many sweets did they share? Mark received 8 sweets. Jason received 12 sweets. We've solved to get that Mark received 8 sweets. And from the question, we know Jason received 12 sweets. So the total number of sweets they had to share is Jason's share of the sweets, which is 12, plus Mark's share of the sweets, which is 8. So we have 12 plus 8. 12 plus 8 will give you 20. So they shared 20 sweets. Also note that this question can be solved the traditional way, or what we can describe as the traditional method. Solving a ratio question the traditional way means you have to add, like in this case, the two ratios. That's 2 plus 3, that's 5. Then for Jason, you take his own ratio, which is 3 in this case, because he received the larger share. That will be 3 over 5 times the total number of sweets they shared should equal the number of sweets he received. Let's just solve so you can better understand. Going back to read the question, Jason and Mark shared some sweets in the ratio of 2 to 3. Jason, who received the larger share, received 12 sweets. How many sweets did Mark receive? B. How many sweets did they share? We already know the answers are 8 sweets and 20 sweets. But using the traditional method, would we still get these same answers? Let's go on to prove it. Since we have the ratio for Jason and also the number of sweets Jason received, we can use these two information about Jason to find the total number of sweets they shared. That we are saying for Jason, he received the larger share, that his ratio is 3 over the total ratio, that's 2 plus 3, you have 5, times the total number of sweets they shared, that's X, should give you the total number of sweets you received, which is 12. Standard in a basic ratio question, you're usually given the ratio and the number of sweets they shared, and you're asked to find the number of sweets each will receive. So here, you are given the number of sweets Jason will receive. It's like you are given the answer and you are told to find a part of the question. You can say this is X over 1. So you just solve this algebraic question now. You have 3 times X, that's 3X, over 5 times 1, that's 5, equals 12. We want X to stand alone on the left. So we start getting the 3 and the 5 off. We can get both of them off together, but it might seem a little complex for some students. So we'll take it bit by bit. To get it done quick, you can just multiply both sides by 5 over 3, which is the reciprocal of the coefficient of X in this case. That the coefficient of X is 3 over 5. So if we multiply both sides by 5 over 3, we get the X to stand alone. But if we're taking it gradually, we can standard say we multiply both sides by 5 to get this divided by 5 off first, or we can cross multiply. Students are more used to cross multiplying, so we have this over 1, then we cross and multiply. Let's start with the one that has the unknown. We have 3x times 1 on the left, 3x times 1 equals, on the right of the equals sign, we have 5 times 12. 5 times 12. Now we're looking for the total number of sweets they shared, which is X in this case. Anything times 1 is that same thing. 2 times 1 is 2. 4 times 1 is 4. So 3x times 1 is 3x equals 5 times 12, that's 60. We're looking for X, so we divide both sides by 3. Divided by 3, divided by 3. 3 cancels 3. X equals 60 divided by 3, you get 20. So the total number of sweets they shared is 20 sweets. So the answer is the same as the one we got using the first method, which is 20 sweets. Now that we know they shared 20 sweets and Jason received 12, we can then calculate Mark's share, which is what is left. So out of 20, you take 12 for Jason. The rest will be 8 sweets, which is actually Mark's share. That is, you have 20 minus 12 will give you 8. So Mark received 8 sweets. Hope you understand. You can learn both methods because in some cases, particularly where you might have a ratio question with a bit of algebra, the first method might be more suitable in solving the question. But it's best you understand both methods, or let's say the three methods, because the first two are quite similar while this is the traditional method. Hope you understand.